Am I on? Yes, I can hear myself, so it must be going well. Welcome to the first day of reInvent, or the end almost of the first day of reInvent. It turns out a minute is a very long time when you're standing up here waiting for these things to start, so I'm sure it takes a while for you. So thank you for all being ready and waiting and sitting down and ready to go. So I'm pretty sure all of you, regardless of what you're doing in AWS, want to build highly available and secure applications. Now, this is an introductory session. Some of you may be here wanting to ramp up on something that your company or your team or someone you've spoken to already uses, and you're going to get familiar with that before you dive right into an existing setup. And some of you don't use AWS today, you don't use VPC today, and you want to understand it before you get going, right? And this talk is for both of those groups of people and probably a bunch of groups of people in between. Now, no matter what you do in AWS, there are really two foundational things that it's really good to understand. And those two things are VPC, or Virtual Private Cloud, and IAM, or Identity and Access Management. I'm Gina Morris. I'm going to be teaching you about the first of those, VPC. So what is it? Well, virtual. You're running your virtual infrastructure in AWS, and so we're giving you a virtual network, your own virtual private cloud. Private. It's entirely under your control. You get to pick what goes where, what's connected to what, how it works, how it functions. And then, see, it's in the cloud, it's in AWS. Again, this is an introductory session. That means, like, if you've already used VPC, if you already understand all the ins and outs and security groups and subnets and VPN tunnels, all of this is totally familiar to you, this might not be the right session for you. So if you want to leave, I won't judge you for it. That's great that you already know VPC. Now, the rest of you, some of you may consider yourself to be networking experts. And that's great, right? You're going to see a lot of stuff today that's really familiar. The concepts are really familiar. But in almost every case, what you're trying to do is going to be easier and simpler to achieve with VPC than it is in a traditional data center. An example we'll go through later is security groups. It really simplifies firewalls. Those of you who aren't networking experts, don't worry about it. You guys will be fine too. I'll introduce some of the concepts that are really key and important to understanding VPC. And the thing here is, I don't want you to have to become a networking expert to be able to be productive and be secure in AWS. I want you to be able to focus on your core business and let us handle the networking side of things. So when you're running your virtual infrastructure in AWS, say an EC2 instance, you want to scale. EC2, the E stands for elastic. There we go. And so you're going to be wanting to be dynamic. You want to change around things. You want to replace things with bigger things. And you're running all of this virtual infrastructure of yours in our network, in the AWS network. But it's your virtual infrastructure. These are your resources. So we want you to be able to run those in your own virtual network, in your VPC. And we want to give you control. We want you to let you pick the IP addresses that you want. We want to give you the tools to be able to build high availability applications. And so we do that with something called a subnet. We want you to have control of what connectivity different resources and different parts of your network have, either to the internet or to other networks. So what are we doing in this session? What am I going to cover? We're going to start, first 20 minutes or so, just going through the basic anatomy of a VPC. And that should get pretty much everyone set up with something or able to be productive in kind of a pretty basic and usual way. Once we've covered that, I'm going to deep dive into a couple of different connectivity options and basically just different ways that you can fine-tune your VPC to make it the most functional for your use case. So the simplest VPC is going to be a VPC with internet access. And in fact, most of you, if you have an AWS account, already have a VPC like this called your default VPC there today. We create it for you to make your life simpler. And you can use this. But even if you're using this, it's still good to understand what all the moving parts are and how you can tweak them and change them to best suit your needs. So what do? Firstly, we're going to talk about how to choose an IP address range, because when you create a VPC, that's the first thing you do. We want high availability, obviously. I want high availability. I can't see any reason you wouldn't. So we're going to talk about how you use subnets to leverage availability zones. Once we've kind of got our network set up, the foundation, we want to talk about how we actually send traffic. That's kind of the point of a network. And lastly, we'll talk about how do we make sure, now that I'm sending traffic, how do I make sure I'm only getting or sending or receiving the traffic I actually want? So networks need IP addresses to be able to send traffic. If you think about the letter sending mail analogy, I have a letter. To be able to send it somewhere, I need to know where I'm sending it, and that's what your IP addresses are. And with VPC, you have control over what those IPs are. Now, networking experts, even people who don't consider themselves networking experts, you may recognize this notation. This is CIDR notation. That stands for classless interdomain routing. And CIDR notation is used to denote a range of IP addresses. And this is going to be used over and over again, which is why I should introduce it. So what we have here is an IPv4 example. IPv6 addresses use the same concept. And what happens is you write that IPv4 address out in binary, and you get a 32-bit number. Now, that /16 means hold those top 16 bits steady, and you can vary the lower 16 bits. So this gives us IP addresses that are in the range, or start with 172.31.something.something. Any IP address that looks like that is part of this IP address range. So let's say we choose that 172.31.something.something address range for our VPC. Cool. Why? Well, you can choose just about any IP address range for your VPC, but there are a couple of things to keep in mind and reasons that you might want to choose them. So the first is following convention. Especially if you're working on a network that you share with other people, or you want to send traffic from your network into other networks, it's really good to follow convention so that when people look at the traffic, they look at those packets, they look at those IPs, they know what they're looking at. And it doesn't conflict with something out there on the internet. RFC 1918 simply denotes private IP address ranges. The second thing we recommend is a /16. That's big. That's over 65,000 IP addresses. Now, you might say, well, you know, I want to launch one instance, and I don't really need 65,000 IP addresses. That's cool. It doesn't cost you anything. So why not give yourself the space to grow, and you can use them or not use them, and that's fine. The only other thing to really think about when picking your IP address range is other networks that you may want to connect your VPC to. And this could be other VPCs. This could be your own on-premise data center. You don't want those IP addresses to overlap. This will simplify your life later. So pick something that doesn't overlap if you possibly can. Now, we want to build highly available applications. And in VPC, you do this by using subnets, which are basically subnetworks or subranges of your VPC address space. So AWS has this global infrastructure. We have 19 geographic regions, and we're continuing to expand and launch in more regions. When you create a VPC, your VPC is across one entire region. And a region is then broken up into availability zones. Now, availability zones have redundant power. They have redundant networking. They basically have completely separate failure characteristics. So you can see why you would really want to be in multiple availability zones. As I said, when you create your VPC, it's across all of the availability zones in a region. So you create subnets, and your subnets are limited to one availability zone each. So then when you go to launch an instance, you provide the subnet that you want to use. When you create an RDS database, you provide the subnet that you want to use. And you're basically saying, here is the availability zone that I want you to use. Again, you use CIDR notation to carve out a sub-range of that network, that VPC. So here we've got 172.31.0. something, and so on for the other availability zones. So just to recap, nice big VPC, lots of space for later. We recommend at least a /24 subnet. That gives you 251 usable IP addresses. Those of you who are like, should be 256, yes, but we reserve 5 of those IPs. And then we also recommend strongly that you create subnets in multiple availability zones, because that's going to be how you actually leverage multiple availability zones. Now, last point, if you're not sure about that /16, if you're not sure about how much space you'll need, you can actually resize your VPCs by adding additional CIDR ranges later on, up to 5 of those. So in your VPC, by default, when you create a VPC, you're getting an IPv4 VPC. But you can actually run with both IPv4 and IPv6 addresses in your VPC. We give you a huge number of IP addresses. So you get a /56 VPC and a /64 subnet. And those numbers are pretty long. I didn't bother trying to figure out exactly how many billions they are, but if you feel like it, you guys can work it out and let me know the answer. That was just laziness, not because I can't. OK, so just to demonstrate what this looks like, this is that same diagram from earlier. And your VPC will now have an IPv4 address range and an IPv6 address range. And similarly, on each of your subnets, you can go and add an IPv6 CIDR range to each subnet. Right, so we have this network, it's all set up. Now we want to actually send traffic. We want to be able to communicate from A to B, core concept of a network. So in AWS or in VPC, you do this with something called a route table. And a route table is going to define what traffic to send where. It's basically an easy-to-read list of rules that says, if traffic looks like it's going here, send it over there. In VPC, when you create your VPC, you get a default route table, and that applies to your entire VPC. But you can override that on a subnet-by-subnet basis. We'll come back to that later. So for now, we're going to just stick with one big route table for our whole VPC. So all my examples, by the way, are in the console, but you can achieve all of this using the console or the EC2 APIs. So when you create your VPC, you get this new route table, or if you create a new route table, you get this, this brand new route added in. And we've got one for IPv4, one for IPv6. And they're basically saying, if the traffic looks like it's going somewhere in my VPC, route it local. Keep it inside of the VPC. And that's great. If the traffic is destined for any other location, I don't have a route, drop it. I don't know what to do with it. And that's great. Sometimes that's what you want. But that's not what we want here, right? We want to create an internet-connected VPC. So you do that by creating an internet gateway. An internet gateway is a virtual device. It's an abstraction over something highly available. And to send traffic to the internet, you send traffic to the internet gateway. And back to the route table, all you do is you add a route that says traffic that doesn't match that. This is the default route. Traffic that matches anything else, right? 0.0.0.0/0 is like the wild card of IPv4 addresses. Similarly for the example IPv6 address. If it doesn't match any of the more specific routes, send it to the internet gateway. So now we're able to send traffic to the internet. And the flip side of that is you're also able to receive traffic from the internet. Cool. But you don't want to just get traffic from anywhere, right? There's a lot of stuff out there. So that brings us to network security. And in VPC, you've got a powerful yet simple tool in the form of security groups. And in a traditional data center, you would achieve the same kind of thing using firewalls. And you want your security groups to be easy to reason about, easy to understand. And so the way to think about this is, in a security group, the members of that security group share a common purpose. So let's look at an example. So let's say I have some web servers, and my web servers take requests from the internet, web requests, and in processing those requests, they turn around and they make their own request to a backend server. Cool, response goes in, standard model here. And basically, we have two different groups. Different rules apply about what traffic we want to get to the web servers and what traffic we want to get to the backend servers. We want to allow web traffic from the internet. We only want to allow traffic from our web servers to our backend servers. So let's look at how that looks in security groups. So the web server example, pretty simple. We're just saying allow HTTP traffic from anywhere, this wildcard CIDR range. And that's pretty straightforward, right? Don't allow SSH, don't allow random port 123, don't only allow HTTP traffic. The backend example is a little more interesting. So here you'll notice that the source isn't a CIDR range. The source is another security group. It's the web server security group. So what you've got here is a really powerful, dynamic way of practicing the principle of least privilege. Every time you add or remove an instance from your web servers, it's automatically going to have exactly the right access to be able to make calls to and get responses from your backend servers. That's a super powerful tool. And in EC2, in AWS, you want to be elastic. You want to be dynamic. You don't want to be tied down and having to manually go and update these rules by IP address. So this is really, really powerful. So to recap, security groups are your tool of least privilege. And both of those examples were for ingress security group rules. They were saying, hey, which traffic should I allow in? Drop everything else. But you can also set rules on egress traffic. So what traffic can I send? Don't allow me to send anything else. You can use those, depending on your use case, however makes sense. So far, hopefully I haven't gone too fast. So far you have everything you need to know to really be productive and be secure in AWS with VPC. Those were the basics. That's all there is to it. So now let's have a look at how you can fine-tune your VPC to really get the most out of it for your use case. So we're going to have a look firstly at actually having more control over what kind of connectivity you have. That example from earlier, you had access to the internet and from the internet across your entire VPC. So let's look at how you can lock that down a little bit more. Then we're going to talk about connecting to other networks. And there are two different groups here, right? One is, how do I connect my VPC to some other VPC, either in a different account or in my account or in a different region? How do I get into VPC connectivity? And then the second thing, and this is surprisingly super, super relevant, a lot of you have data centers, a lot of you have on-premise networks, and you want to be able to connect your own VPC to your own network. And so we're going to have a look at different ways of achieving that. So that earlier example, I mentioned that you can do routing on a per subnet basis. So let's go back to our web server, backend server example. We had different requirements for connectivity. Now, I haven't drawn the security groups yet. You would still use security groups, right? Two different ways of protecting yourself here. But I'm leaving them off for simpler slides. So you can put your web servers in one subnet and give that subnet a route table that actually has a route to an internet gateway. And you can put your backend servers in a second subnet that has no route to the internet, because they only ever need to get requests from the web servers, which are inside the VPC. You can do this, a lot of compliance or auditing requirements will say, you can't, or you have to show that your resources are not routable from the internet. This is one way of doing that. And then a lot of people just want to take a bit more of a belt and suspenders approach to security and use both routing and security groups to lock down what can and cannot be accessed from the internet. So again, the previous slide was a little bit of a simplification. I wanted to re-emphasize, you've got multiple availability zones. Hopefully, you've gone and you've built your application across multiple availability zones. So you have your web servers in multiple availability zones, as well as your backend servers. And this means you actually want to create a public subnet in each of those AZs and a private subnet in each of those availability zones. You can associate the same route table with all of your public subnets and the same route table with all of your private subnets to achieve the same thing. So another use case for wanting to have access to the internet, but not really wanting to be routable from the internet, is things like, I've got a server. My server needs to get software updates. I need to reach out to some repo, and that repo happens to be on the internet. I don't want my VPC, I don't want my resources or my server to be routable from the internet. How do I fix this? Well, you can use network address translation, or NAT. And you can do this in a couple of ways. Let's just do that. There we go. So we've got a public subnet, we've got a private subnet. I want one of the servers in my private subnet to be able to access its repo out there on the internet without being routable. The two ways you can do this are, firstly, by running your own instance in your public subnet and performing network address translation yourself on that instance. Alternatively, you can use something called a NAT gateway. A NAT gateway, again, it's a highly available virtual device. It's not a single point of failure. And so all that you have to do to get this to work is you put a public IP address on that NAT gateway, and then you route traffic from your private subnet to the NAT gateway. The way NAT works is basically you get your private IP on this end, you go to the NAT gateway, it stores a map of which private IP was sending traffic, it goes off to the internet. When the response comes back, it knows about which private IP originated that, maps the traffic back to that, and off it goes, right? So you achieve that outbound-only internet access without having to open up your whole subnet to the internet. And there's your route table, same as we did with the internet gateway. IPv6 doesn't really have NAT, and the reason for that is IPv6 addresses, you don't really have private and public IPv6 addresses. They're globally unique. And so what we've created here is, so in your public subnet, you would just have a normal internet gateway. What we've created here for IPv6 to achieve this kind of outbound-only behavior is something called an egress-only internet gateway. All this is doing is it allows traffic originating in the private subnet to go out, but it doesn't allow traffic originating outside to come in. Again, you just create a route. So how many of you here, actually I'm going to ask for a show of hands, how many of you here either have multiple accounts with different VPCs in? Yeah, so show of hands. Oh, okay, there we go. People are getting brave. Good for you guys. What about maybe multiple VPCs just within one account? Yeah, okay. What about you're operating in multiple regions? So you have a VPC in one region, another, yeah, okay, cool. So lots of different use cases there, right? Now, how many of you have one of those setups and would really love to be able to just talk from a server in the one VPC to a server in another VPC? Some of you? Okay, cool. Yeah, so that happens, right? And maybe you want to share a service. You know, I've got my logging service over here, and I'm doing some stuff, and wouldn't it be cool if I could just send my logs straight there without having to send them over the internet or something? Well, there are a couple of ways that you can achieve that kind of cross-VPC connectivity, and it really depends on your use case. But one of the ways that you can achieve this VPC connectivity is by using something called VPC peering. And VPC peering basically gives you full private IP connectivity between two VPCs. Those VPCs can be in different accounts. They can be in different regions. The only requirement is that they don't have those overlapping IP address ranges. Because, you're sending private connectivity, private IP traffic, right? You need to know where you're sending it. It's pretty simple again. And this is really cool. If you're in the same region, your security groups, your tools of least privilege are going to continue to work. So you can actually reference things by security group and keep that same cool behavior we spoke about earlier. So pretty simple to set up. We don't want one person to just be able to connect two VPCs. So there's a bit of a handshake here. Both sides have to agree. Pretty straightforward. One side asks, other side agrees. And at that point, the peering connection is set up. And the only thing that needs to be done to actually get it to work is that both sides need to set up a route to, say, send traffic that looks like it's destined for the other VPC to that peering connection. Now, some of you may notice that there is a route to a VGW, which we haven't spoken about yet. We're going to talk about that next. So we spoke about those of you who had multiple VPCs. How many of you have an on-premise network, your own data center? Yeah, a lot of you, for those of you who didn't want to turn around. So if you wanted to securely and privately connect your VPC to your own on-premise network, there are two different technologies for doing that in VPC. Now, some of you might be thinking, well, why would I want to do that? Well, if you're migrating, right? So if you're trying to move some or all of your applications from your own on-premise network into the cloud, it's really, really helpful to be able to transition gradually, not just lift and put it down. The second thing is if you want to operate in some kind of hybrid model, right? So you want to run parts of your application on your own equipment, and you want to run some of your applications in the cloud, you can do that as well. Now, little brief segue here. I'll try and keep it to a short story, but some of this is kind of the genesis of VPC. So way back when EC2 launched, you didn't have VPC. It didn't exist. You launched an instance, and you got an instance, and it had a public IP address. You had internet access, and you got a 10.something IP, private IP. You didn't have control over what that IP was. And that's fine. And at the time, very progressive. But if you had your own data center and you wanted to be able to connect your data center up to your resources in EC2, you were just out of luck if your own data center started with 10.something IPs, because overlapping IP address ranges. And so VPC kind of came about as a way to give you, as the customer, control over both sides of that connection, giving you that control that we spoke about earlier of why would you care? Why would you care to pick your own IP address range? This is exactly why. So there are two technologies for achieving connectivity between your on-premise network and your VPC. Those are AWS VPN, or Virtual Private Network, and AWS Direct Connect. And I'm going to describe each of these, but at a really high level. And the reason for this is they're massive topics on their own. So if this is a use case that you're interested in or you want to know more about, I definitely suggest going to one of the deeper dive sessions on each of these technologies. So let's look at VPN first. So on your own data center side, you'll get your own networking device. And following our documentation, where we have step-by-step instructions, you'll set that device up to act as something called your customer gateway. And that's going to be your on-premise end of that VPN connection. Then on the VPC side, you're creating something called a virtual private gateway, or a VGW. And this VGW is going to be the VPC end of that connection. Now, if you've set this up correctly, you're going to get 2 encrypted IPsec tunnels. They're redundant. They're going to send that traffic over the internet. And we really suggest that you set these up so that they terminate in 2 different availability zones so that you can get that redundancy, that higher availability. And then the last thing you need to do, just like with many of our other examples, is set up that route to say traffic that looks like it's destined for the private IP range of my on-premise network, send it to that VGW. So direct connect, there's a little bit more going on here, so we're going to introduce the sort of pieces one at a time. So we've got the AWS network. And in AWS, you're running your VPC, and you've got your virtual private gateway, the same kind of setup that we had for the VPN. And then you've got your on-premise network. You've got your own networking devices and so on. Now, with Direct Connect, just like the name implies, you're creating a physical connection, a direct connection between your own equipment and AWS. And so the way that we do this is either you, or if you're working with a partner, will put your hardware, your own networking devices, in a physical location that is shared with some AWS devices. Now, this is going to be a carrier-neutral location, something like Equinix or CoreSite or Interaction. We have this, different sites, different options all listed in our documentation, and they vary region by region. Once you've set this up and you've gone and configured everything, you can create 2 types of virtual interfaces. The first type is a private virtual interface. And a private virtual interface is going to give you private IP connectivity over this physical connection between your on-premise network and your VPC. And then the second type of virtual interface you can create is a public virtual interface. And a public virtual interface is cool because it gives you public connectivity to public AWS IP space. And so this means if you're running an application on your on-premise network that wants to maybe get some data out of S3, you can get that data along that direct connect link. You don't have to go over the internet to get that information. So you keep practicing almost that same principle of least privilege where you're not doing more or going outside of the bounds that you've set up in this connection. Now, we've spoken a lot about routes. And static routes, if you think about it, are these manual routes that you're going in and you're saying, hey, traffic that's going to 1, 2, 3, 4, send it to this gateway. If you have a lot of those, it can get pretty complicated, and it might get hard to maintain if you're trying to update them a lot and so on. And so you can use something called BGP, that stands for Border Gateway Protocol, to actually propagate routes from your on-premise network into your VPC. Now, especially if you're operating in a setup where you have multiple different direct connect connections, you can actually change the number of hops on each of these routes that you propagate to actually help direct the traffic along certain paths. If you're already familiar with BGP, this might make total sense. If you're not, you might need to go and do some reading. I'm not going to try and deep dive too much further into this, but the high level is you can propagate routes and simplify some of that management if you've got a lot of different routing changes and stuff going on. So in summary, the basic concepts of VPN and Direct Connect are the same. You're connecting your on-premise network to your VPC, but they're different methods, and the one you choose is going to depend on your use case, your needs, and it very often comes down to your data transfer requirements. So we've spoken about VPC, we got the basics, we've spoken about other places and connectivity. Now what about the rest of AWS? I know you're all in this room to learn about VPC, but I suspect you came to AWS's reInvent conference not just to learn about VPC. If you did, cool, that's okay. But I suspect you came to reInvent because of the wide variety of services that we offer and some of the exciting changes that are going on. So let's talk about some of those other AWS services that we have. We're going to talk about DNS with Route 53 and how you can do cool stuff in your VPC using Route 53. We're going to look at various AWS services that run inside of your VPC. Then we'll talk about how you connect privately to other AWS services or to other services running in VPCs. Remember when we spoke about VPC peering, I said there were multiple ways of sharing services. This is one of the others. And then lastly, I'm going to show you how to get visibility into what on earth is actually happening in your VPC using VPC flow logs. So one very basic service of a network is DNS, which is used for domain name resolution. And with VPC, you get split horizon, or the ability to set up split horizon DNS. So when you create a VPC, there are two DNS options. And we suggest that you say yes to both of those, because they're going to give you some useful tools without you having to operate any kind of machinery. With Route 53, which is our managed DNS service, you get the ability to take over a zone in your VPC. So in this example, I've made example.demohostedzone.org resolve to one of the IP addresses, one of the private IPs in my VPC. So if I'm outside my VPC and I try and resolve that DNS name, it'll resolve to one thing. When I'm inside my VPC and I resolve that DNS name, it'll always resolve to that private IP address. And so you can set up some pretty cool stuff with this. So you've got your own managed infrastructure. You're running AWS services, and managed infrastructure is basically stuff that we're running on your behalf. So it's your infrastructure, right? And you, therefore, want to probably run it in your data center, your virtual data center. And there are really two patterns that you'll see repeated over and over again with different services that allow you to take advantage of AWS's global infrastructure. And this is all to let you get much higher availability with those services. So the first one I'm going to look at is Amazon RDS. Running a database with RDS, you get the option to run your RDS database in your VPC. And the first thing you're going to be asked about is security groups. And these work exactly the same as we discussed earlier. You're defining the amount of privilege or the amount of access that different things need. The next thing you'll always be asked about is subnets. And when a service is asking you about subnets, what they're really asking you about is, which availability zones do you want us to use? Now, with RDS, if you specified two different subnets in two different availability zones, you're going to get a master in one availability zone and a failover candidate in another availability zone. So that redundancy, you're taking advantage of that redundancy, and you're taking what I call the active standby model here, where you have an active resource in one, a standby resource in the other. So if anything happens in that first availability zone, you'll be failing over to somewhere completely separate. Application load balancers use what I would call the active-active model. Again, you're asked about security groups, same story. And again, when you're asked about subnets, you're being asked to specify what availability zones do you want this application load balancer to be load balancing across. And with application load balancers, when you specify multiple AZs, active-active model, you're active in all of those availability zones that you specified. You're redundant across multiple availability zones. Now, I'm not going through any other examples because these patterns just repeat over and over and over again for different services. So direct private connections to AWS services, right? We spoke about locking down your VPC, restricting internet access for a variety of reasons, security, belt and suspenders approach to security, auditing, compliance, things like that. but you still might want to get your data out of S3. You still might want to use the EC2 APIs. So this is one of the ways of achieving that, is with VPC endpoints. So let's have a look at how accessing S3 as an example, but this is the same for other services, how that works today. So you've got your applications, they're running in EC2, and you've got your data, and your data is sitting in an S3 bucket. Cool, pretty normal approach here. But when you resolve that S3 location, you're getting a public IP address because S3 is a public service. And so to access your data in S3, your traffic is going to try to go over the internet to get the data. And if you have internet access, or if you want internet access, that's fine. But if you really don't want to have internet access, you're now having to choose between access to S3 and keeping your VPC locked down. So with VPC endpoints, you don't have to do that. There are two types of endpoints. There are gateway VPC endpoints and interface VPC endpoints. Now, gateway VPC endpoints are what we use for S3 and DynamoDB. And just like all of the other gateways we spoke about, you route to them using the route table. So you'll create this gateway VPC endpoint, and it's just going to work. You have a route table. It says traffic that looks like it's destined for S3. Send it to the VPC endpoint. You're not going to change your code. You don't have to do anything. It is just going to work. There's some other really cool properties of gateway VPC endpoints. And again, allowing you to practice the principle of least privilege. Specifically, you can add a policy, an identity and access management policy, onto your VPC endpoint that can control or allow you to control exactly what operations that VPC endpoint can make against that service. In the S3 case, you kind of have a double header here. In the S3 case, you can actually put a policy on your bucket to say only allow access from this VPC endpoint. Don't allow access from anywhere else. So the other type of VPC endpoint is an interface VPC endpoint. And these are, it's nice music, background music, guys. So interface VPC endpoints are backed by a technology called Private Link, AWS Private Link. Now, many other AWS services are supporting VPC endpoints using Private Link. And the way it works is when you create the VPC endpoint, it creates elastic network interfaces in the subnets that you specify. So again, multiple subnets, multiple availability zones, right? So you create these private IP'd ENIs, and when you send traffic to these, it's going to send private IP traffic to the service that that VPC endpoint is for. Now this, again, this is not a single point of failure. This is another highly available virtual device that's fronting the service here, that's creating this virtual VPC endpoint. So because this isn't a gateway, you don't route to it with a route table. I think this is one of the first examples we've had that doesn't use a route table, right? Because it's IP addresses, you're going to be using DNS to send traffic to the VPC endpoint. And we create a DNS name for the whole region for that VPC endpoint. But then we also create a DNS name for each availability zone so that if you want to keep your traffic within an AZ, you can do so. Now, some of you might be looking at this and saying, oh, now I've got to go and change my code to point my endpoints at the right place. Yeah, we don't want you to have to do that either. And so if you selected yes to those VPC DNS options, we'll actually create a DNS name and we'll manage it for you in your VPC so that you don't have to change anything, so that we just use the service name as it's specified, and whenever you resolve that from within your VPC, you get these private IP addresses. One really, really cool thing about Private Link and VPC endpoints is that if you have your own service and you want to share that either with other VPCs in your account, if you are a service provider and you actually want to offer that as a third-party service, you can do so. without making your service publicly accessible. So you can actually make your own services available over VPC endpoints just like those AWS services are. So if you're the service provider, you just need your service behind a network load balancer, and then you go in the console and you create a VPC endpoint service. At that point, a consumer can come along. There are different models for how much you share this and whether it's publicly visible and so on. But say you don't want to share it widely, you're just going to tell your friend the name of your service. They can go along and create a VPC endpoint for your service using the name you gave them, and it'll work exactly like we spoke about for those EC2 APIs. Again, you get a DNS name for your service. And on the consumer side, that's what it looks like. They don't have to know anything about your architecture. They don't have to know anything about the IPs of your VPC. They're just seeing, I'm sending my traffic to the VPC endpoint for this service, and it's just working. So we've covered quite a lot of stuff. We've spoken about a lot of different ways of securing your network, for example. And so you might want to know, well, how do I get visibility into knowing, are things working? What are my security groups doing? Just like, is it working as I expected? Maybe you're troubleshooting, maybe you're auditing, something like that. And you can do that using VPC flow logs. Flow logs are super useful, and you don't really have to manage, or you don't have to manage any infrastructure to get them set up. So to set them up, super quick and easy, you just go to the VPC console, to the Flow Logs tab, and you click Create Flow Log. And then we walk you through what you need to get going from there. And you can see in this example, I have it set up to send traffic both to S3 and to CloudWatch logs, so different locations depending on how you want to consume that data. Here's an example of what your flow logs actually look like. This is in CloudWatch logs. And so I had an example. I made it up for you guys. I set up a security group to allow HTTP and SSH and to reject everything else. And so you can see here, we say, hey, I accepted this traffic. It was HTTP traffic, so on TCP port 80. And then you can have a look at who sent this traffic. In this case, it was another instance that I was running and pinging between these things, so there you go. And it works the same for IPv6 traffic, so you can actually go and have a look at both your IPv4 and your IPv6 traffic and see exactly what is and isn't working, what's being rejected, and so on. So to wrap up, what have we gone through in this hour? I think quite a lot. We spoke about your network, your virtual private cloud, and your resources in AWS. We spoke about how to actually do networking in AWS, how to leverage the different fundamental VPC components to set up your network so that you can actually leverage it for higher availability. We spoke about security, really, really important to have good network security, to be able to control who can talk to whom in a low-maintenance way following the principle of least privilege. We spoke about running AWS services inside of your VPC and how you get the best or the most out of that. And then we spoke about, right now, about getting visibility into what your security groups are actually doing. We spoke about connectivity, and again, there are so many different connectivity options. I really do suggest if there's some kind of connectivity you want to know about that we didn't cover here, come ask us at the booth. I'll take questions afterwards. I think they asked if we'll go into the hall. But there really are a lot of different types of connectivity we didn't cover here today. We spoke about internet connectivity. We spoke about connectivity to your on-premise data centers using VPN and Direct Connect. We spoke about connectivity between VPCs using peering, using VPC endpoints in some cases. And we spoke about how to get connectivity to AWS services without having to go over the internet using VPC endpoints. All of this is intended to give you a visible, flexible zero maintenance, and entirely under your control network that you can use to run in AWS and be secure and highly available. Now, in terms of related breakouts, there are so many sessions that are relevant or related to this one. And so I picked some of the ones that I think are pretty related to what I spoke about. If this was kind of set at the right level for you, if you were like, yep, I learned some stuff, this was good, I definitely suggest going to Net 202. That one's going to go more into a deep dive of how you really, really secure your network and secure your data center, your virtual data center in AWS. So at this point, you should have everything you need to know to be productive, to be secure, and to get up and running with VPC. So if I've done my job right, you won't have to come to this session next year. So thank you very much, and don't forget to fill out the survey.